Okay, welcome back. Question 2 of paper 1 2018. Let's do this. So first one, we've got a diagram, very simple setup that we use in class, or a very standard setup that we've done in class. We've got a ray of light that's going into a glass block, and what we need to quickly identify is what this angle Y represents. So going in, this is our incident ray. Here is our incident, not a particularly fascinating incident, but an incident nevertheless. And so X is our angle of incidence, and the process that I hope you remember that happens when light changes direction as it changes speed going into a different medium is refraction. So Y is the angle of refraction. That's question, 2A. That's just one mark. And multiple choice, angle of refraction. Okay, nice one to get us started. Next, we get a little bit trickier straight away. So we've got a graph of angle Y against angle X. And we are asked to calculate a value of angle Y divided by angle X. So angle Y divided by angle X. And really what you can do is take any two coordinates from the graph and do angle Y over angle X and get a value. Now, what I would do is I would always look for a bit of the line that clearly kind of crosses through an easy marker on your diagram. So what I mean is if you look along and you find the bit that has 14 for angle X, it should pass through a nice line. I'm not sure I've done this to scale very well, but it should pass through a nice line for 9. See if you can find that point. But do you know what? Whatever you've done, I'm going to tell you the values that it needs to meet. But if we took the point that is 14 and 9, so 9 divided by 14 gives us 0.64. That will very much do for us. Then happy days, we're all good. But any value that you get that is between 0.6 and 0.7, okay, is going to get you both of those 2 marks. So see hopefully what you did got between that value, or play around with another couple of values from the graph. So long as you're careful and you take your time, you should get a value between 0.6 and 0.7. Okay, so that was part A, part 2. Part 3, we now get 3 marks. Let's make sure this comes up on the camera. We get 3 marks for the following question. The student concludes that angle Y is directly proportional to angle X. Explain what the student must do to test this conclusion in more detail. So hopefully what we need to be recognizing is that so far it looks like there might be a directly proportional relationship because we have a linear graph. Okay, if we were to double angle X, we would double angle Y. Well, that's what it looks like. So we need to test that conclusion in more detail. What you need to identify then is, therefore, we want to get more angles of X, or measure more angles of X, or set up more angles of X and measure Y. So just going up to the diagram again, change the angle of incidence, measure the angle of refraction, and if it were to be directly proportional, hopefully what we'd see is that we'd get a load of values that would go along that line like so. But what we just have to say is what we would do. So we would repeat with more values of X larger than 20 degrees. Okay, and actually it's as simple as that. Well, easy when you know how, but repeating with more values of X larger than 20, and that would give us the graph extending, and if it were directly proportional, it would look like that. Now, just a little note on repeat. If you get a question on how to improve a method, you're never going to get marks for saying that you should repeat it. If it's how should you improve the method, you need to talk about specific ways in which the experiment was done that you would change or adjust. Repeat does work here because we're trying to get more data, so we need to repeat the same method but changing the angle of incidence. The method's the same. We shine a ray of light into the block and we measure angle Y. We're just repeating with more angles of X. Yeah, fresh page. And we have part B. Not really much connection here, part B, to the rest of the question, other than we've got an equation to do with light. The speed of light we're given the wavelength of yellow light, and we've got to calculate the frequency of yellow light. We are given the equation, so this is not one you're going to need. Well, sometimes you'll need to remember this equation. In this particular question, that's not what they're interested in. They're interested in, or two things: your calculation, but also the unit. So there is a mark in this case for the unit. Remember, units are not a number, they're the thing that we measure it in. So the unit of time is seconds, the unit of distance is meters. So we need to know what the value is and what the time. So we've got the speed of light is equal to 3.0 times 10 to the 8. Written that very clearly, apologies, meters per second. So that's 300 million meters per second. And the wavelength of the yellow light is equal to 5.8 times 10 to the minus 7. Apologies, meters. And we need to work out the frequency. So we're simply just putting that into this graph. And maybe, this is a test of using large and small numbers, but hopefully you're able to do that. 3 times 10 to the 8 divided by 5.8 times 10 to the minus 7. And that gives us this value for frequency, 5.17 times 10 to the 14. I'm going to leave it to two significant figures because that's the data I'm working with here. So 5.2, I've no space there, times 10 to the 14, and the unit for frequency is hertz, and you can just put HZ for that. Okay, that is question 2 completed for you. See you next time.